Hey kiddos, today we are going to start section 6.1, so you should have gotten your new note packet from the sub. Go ahead and get that out, open to 6.1. We're going to work on graphing exponentials today and growth and decay functions. So let's take a look here. Okay, so it says graph using an XY chart. We're going to fill in the chart here. So if I plug in -2 for x, I get 3 to the -2. The chapter we just came out of, that gives us 1 over 3 squared. So this would be 1/9. 3 to the -1 would give me 1 over 3. 3 to the 0 power. Well, remember, anything to the 0 power is 1. And then the rest of these are mental math. 3 to the first is 3. 3 squared is 9. So let's go ahead and graph those points. I have 0, 1, 1, 3, 3, 9. And then over here on the left with -1, 1/3, -2, 1/9, hard to graph there. And we will connect those dots. Looks like this. Okay. And what we just graphed is called exponential growth. Okay. So y growth from left to right, the y values increase. Okay. So when we talk about the domain of our exponential functions, well, we saw that we could plug in -, 0, 1. The domain is going to be all real numbers. But the range is going to be based off of what we call a horizontal asymptote. There's an imaginary line down here. If I put it in, it's right here, where this red line is never touching that blue line. So on here, what is a horizontal asymptote? It's an imaginary line that is never touched. So if we get really, really close to this blue line and we don't touch it, that means that our range would be y is greater than or equal to 0. And I think I just said greater than or equal to, no equal to, just greater than 0. Okay. So the range will always be based off of where that horizontal asymptote is, and we'll talk more about that as we go, of how to find out where that horizontal line exists. So let's do the same thing over here for 1/3. And let's see, let's do this one in purple. Okay, so we're going to plug in our values. I've got 1/3 to the -2. And again, that negative exponent flips that. That becomes 3 squared, which is 9. If I have 1/3 to the -1, negative exponent flips. So 3 to the first. Sorry, that should be 3. Remember, anything to the 0 power is 1. And then 1/3 to the 1 is just 1/3. 1/3 squared is 1/9. So hopefully those numbers are looking familiar compared to the first one. They're just in a different order. If I come over here and graph at -2, I've got 9, 1, 3, and then a similar shape to what's going on the first time, but again going in the opposite direction. So this time we say, well, this is decay, and why? Well, same reason. From left to right, y values get smaller. Okay. Just like before, we can use negative, positive, 0 for our input. The domain is all real numbers. Okay. And just like over there, we have that invisible line again. We're getting close to that green line, but we never touch it, so our range would be y is greater than 0. Again, no equal to part on that. So these are our basic parent functions, and what we want to do is, as we go through, what are the parts of the graph that causes the shifts? How can we tell exponential growth and decay from just looking at the functions? So here we go. Okay, so looking down here, how can I look at a function and tell growth or decay? Okay, so all we want to do is look at the base. Okay, so if the base is greater than 1, then it's growth. If the base is greater than 0, but less than 1, then it's decay. Well, not decay, decay. There we go. Alright, so when I look at number 3, I ignore everything else that's going on there. I just look at the base. So just that number 3. So since 3 is greater than 1, that makes this growth. Pretty easy, right? Number 4, I take a look only at the base, ignore everything else. So I take a look here at the 1/2. That is in between 0 and 1. That makes this graph decay, which means from left to right, the y values are getting smaller. Same thing with number 5. Look only at the base. 5 is greater than 1, so this would be growth. And then take a look at the base. And 4/3. Be really careful with 4/3. Okay, 4/3 equals 1 and 1/3, so this is growth. Alright, I want you to pause the video. I want you to try 7, 8, 9, and 10, and then check your answers and see how you did. Okay, how did you do? Check your work. Looking again just at the bases, I've got 3, so growth, 2/3, so decay, 6, so growth, and remember 5/4 is 1 1/4, so that makes this one growth. Alright, let's go on and keep taking a look at our functions. Okay, so for this next part, I want you to get your graphing calculator out and treat this as an exploration. Okay, I am going to put these all on there for you, but I want you to see if you can figure out, that here's the parent function, y equals 2 to the x with no shifts. How does the -3 on the outside, the -3 up on the exponent, and the negative out front change that parent function? So what I want you to do is pause the video. I want you to graph 2 to the x minus 3 on your calculator, put it on the coordinate plane, and figure out the shifts. Do the same thing for each of them, and then once you're finished, check your work. Okay, so let's talk through these. So hopefully what you figured out with your exploration. So we have the original parent graph. My number 2 is done here in red, and it shifted my entire function down 3, including the asymptote. The asymptote right now is at y equals -3, where it was at y equals 0. So what do you think that number out there that stands alone? That's going to represent where our horizontal asymptote is. When I do a shift up in the exponent, it shifted my graph to the right. So just like our h lies and k tells the truth, -3 sends us to the right, and that negative out front caused a reflection. Perfect. Okay, now I want you to do the same thing with your calculator. We're going to take a look at some exponential decay. Take a look at those shifts. So go ahead and pause the video. Be careful though when you put 1/2 into your calculator, make sure it has parentheses around it as the base. And then let's see if you can figure out those shifts. Okay, so just like before, a number on the outside causes a shift up or down. That's going to be our k value. K tells the truth. A number up in the exponent causes a shift to the right, and then a negative out front causes a reflection. Okay, so on our vinyl page here, I have the general form of an exponential function right here. And let's talk about what all the parts do. Okay, A is the multiplier. Okay, if A is negative, we just learned that it causes a reflection. Okay, B is the base. Okay, and that determines growth or decay, as we talked about earlier. H is our right or left shift. And just like normal, H lies, K tells the truth. Okay, and K is our up or down shift. But the big deal here is your horizontal asymptote is y equals k. So whatever that value is that stands out there alone, that is your horizontal asymptote. So in general, if you know that it's exponential growth, meaning the base is greater than 1, it looks like this from left to right. The y values are getting larger. If there's a reflection, they're getting larger just in the negative direction. Okay. If it's exponential decay from left to right, y values are getting smaller. And same thing, if there's a reflection, we start with larger negative y values and then it gets closer to the asymptote. So, this concludes your first video. Go ahead and watch the second video, and then we will put it all together for your homework.